Let us learn about the logarithm chapter. Students, those who are new to the logarithm, you must know that it is a very scoring chapter. This logarithm chapter is very scoring, and we just have to basically understand how to convert from the exponential form to the logarithmic form, and from the logarithmic form to the exponential. These two conversions you must know very well. Like suppose, as I have written here, a to the power b is equal to x. This is the given form. So this we will do in the logarithmic expression. How? Log of x, that means what is there in the RHS, right hand side, you have to write that log of x to the base a. That means this will come to the base, will be equal to the power. The power will come on the right hand side of the equal to. See this one, 2 to the power 3 is equal to 8. So what will be the logarithmic form? Log of 8 to the base 2 is equal to 3. Easy. Now when we talk about the power, when we talk about the whatever is there in the power, if it is a fraction also, we will take consideration of the fraction. Don't get frightened with the fraction if it is in the power. What we have learned is that simply whatever there is on the right hand side of the equal to, we will take the log of that is log 8. The real number will come to the base, so we will read as log of 8 to the base 64 is equal to 1 by 2, that is half. Where did this half come from? That was in the power. So whatever is there, I said in the beginning just now, whatever is there in the power will come straight to the right hand side of the equal to. Now apart from this, there are some laws, and if you learn the laws, I will be showing you on the due course, and will be solving you also some sums for you to understand better. Again, two more expressions. 0.2 to the power 2 equals to 0.04. This expression we write in the logarithmic is log of, as I just explained, whatever there is on the equal right hand side of the equal to will be log of 0.04 to the base 0.2. That is 0.2 will come here. That is what we see is that, to be very easy to understand, the result will be on the right side of the logarithmic expression. The number comes to the base, and the power comes to the right hand side of the equal to. This way you have to understand. Those who are new to the logarithmic chapter, this will help you to understand. Again, 3 to the power minus 3 is equal to 1 by 27. Those who have already done the powers and indices chapter, you can understand. So log of 1 by 27 to the base 3 is equal to minus 3. That was there in the power that comes on the right hand side of the equal to. Again, now we convert from the logarithmic to the exponential form. So log of 16 to the base 2 is equal to 4. This is given. So this becomes 2 to the power 4 equals to 60. Similarly, log of 0.1 to the base 10 is equal to minus 1 is given. This expression in the exponential form will be 10 to the power minus 1 is equal to 0.1. So these are some of the expressions which we need to know before starting with the logarithmic sums. And the laws, as I said, that there are some law, and those laws will help you to do the sums error free. Like log of 1 to the base 2 equals to 0. That means any form where we see the base is anything given, it may be the algebraic expression, it can be numericals, but if the log is 1, log of 1 is given, it will always be equal to 0. So we can call it a law. This is one law. Similarly, log of 3 base 3. That means what we see here is that whatever is given on the right side of the log, if the same is given on the base, will always be equal to 1. That is log of 5 base to the power 5 equals to 1. If it is a and the base is also a, will be equals to 1. If it is a log of 100 to the power base 100, will be always equal to 1. That means if the log of the number base with the same number will always give you the answer as 1. These are laws. Now there is a product law like log of mn if is given and base can be anything. So we can break it into log of m base a plus log of n base a. That means if in the solution or in the question you find this form, you can obviously write it into this form. Again, quotient form. Log of m divided by n to the base a will be always equal to log of m base a minus log of n base a. That means while solving any sum, if the expression comes out in this way, we can always convert into this form of log. That is log m divided by n. That is called the quotient law. Next is the power law. That says log of m to the power n with a base suppose a will be always equals to n into log m base will be same, that is a. So when we apply these in the sums, as I will show you in the further sums, it will be much more easier. Let us clearly understand the laws with examples. Just now we learned about the product law, that is log mn to the base a will be equals to log m plus log n. Suppose we take an example log 16 to the base a. Can we write the 16 as 8 into 2? So we write like log of 8 into 2. Base will be the same. So this becomes log of 8 plus log of 2. Base remains the same. This is the product law. That means we are breaking the form that is given 16. Suppose here it can be any other form. It can be algebraic form, it can be numbers. So if it is a number, we can break it. If it is an algebraic form like xy, we can write log x plus log y. Base will be the same. Base cannot be different. In the quotient law, we learned that log of m by n to the base a, we can break it into log of m minus log of n. Base remains the same. Base cannot change. So this example we can take that log of 8 by 5 to the base a, we can write like log of 8 minus log of 5. Base will remain the same. So this was the quotient law. That is, if it is a division form, that is a fraction or division given, we can write in the difference, that is the minus. With the minus we can break. Again, in the power law, we learned that log m to the power n base a will be equals to n log m, base remains the same. That is, suppose we take an example log of 16, base remains a. Base can be anything that is given in the sum. So can we write this 16 in the expression of 4 to the power 2? That is 4 square is 16. So this expression we will write like 2 will go at the front. So we can write into 2 log 4. Base remains the same. So this way we break the forms that are given. It was the product law. We broke it by putting addition sign. Is the quotient law, that is division or fraction you can say. We are breaking it by putting the minus sign in between as I showed. And power form m to the power n, 4 to the power 2, it can be, we write as 2 log 4. So we are breaking this form. These are very helpful or useful. Without this we cannot do the sum. So first you have to learn or understand these laws. and the remaining 2, as I already explained before, so the log of a with the base same will be 1. In generally, while doing the sums, if we do not see that in the question log of base is given, we take it as 10 is universally. That means, I repeat, if in the sums, when we do the sums, log the base is not given, we consider it as 10. So in any case, if the answer comes out as log 10, so you have to understand the base is 10. So if both are same, so it will always, the answer will be 1. And here the last law, that is log of 1 to the base a will be equals to 0. That means if it is any base, but if it is the log 1, answer will always be 0. Let us now look into the examples as given. It says if log 64 base is x equals to 1.5, find the value of x. How to do? Let's represent in the exponential form. X to the power 1.5 is equals to 64, or x to the power 1.5 equals to 2 to the power 6. This 1.5 we can present as 15 by 10. So we can write x to the power 15 by 10 equals to 2 to the power 6. And as you have done the powers and indices chapter, you know that now we can write x equals to, this power comes to this side, but the numerator becomes the denominator becomes the numerator. So 2 to the power 6 remains, into this becomes 10 by 15. So here now 3 2s are 6 and 3 5s are 15 and 5 2s are 10. So this becomes as 2 to the power 4. Answer comes out as 32. Look into the next example. Here it says log 0.01 base is 10 equals to minus 2. This is given. It is asked to convert into the exponential form. So this becomes 10 to the power minus 2 is equals to 0.01. As you have learned, the exponential form to the log as well as log to the exponential form, this is the same way. Now whether we have done right or wrong, we can check it. How? To check, we have to do like this. 10 to the power minus 2 is equals to what? Actual value. 10 to the minus 2 means 1 by 10 square. That comes out as 1 by 100. That comes out as 0.01. So this answer and this one are the same. So my conversion is correct. Again, the next example says log of 1 by 5 base is 5 equals to 1. We are asked to convert again into the exponential form as given before, exponential form. So this comes out as 5 to the power. This is actually the power. So 5 to the power minus 1 equals to 1 by 5. And obviously we know 5 to the minus 1 means 1 by 5. So the conversion is this way. Next example, it says log 0.125 base is 2. It is asked to convert and find the value. Let's convert. 0.125 we can write as 125 divided by 1000. Log base is 2. So we, as per the law of quotient, or you can say quotient law says log of 125 minus log of 1000. M by n. Remember, base remains the same. So this 125 we can present as 5 to the power 3 and 1000 can be represented log of 10 to the power 3. Base remains the same. It comes out as, now we can see that log of next is the power of log power. In the power law, we can write 5 to the power 3 as 3 log 5 minus 10 to the 3, we can write 3 log 10, right? So 3 log 5 base is 2 minus 3 log, this 10 we can break it into 5 into 2. Again the product law comes here, where we can write that in the bracket 3 log 5, this multiplication becomes plus 3 log 2, right? So when we open the bracket, it comes out as 3 log 5 minus 3 log 5. So we can, this goes out and we remain with only minus 3 log 2 base 2. And as I showed you that before in the law, that log of any value and if the base is also the same, that comes out as 1. So we can write that 3 minus 3 into 1. Log 2 base 2 is actually 1. So the answer is minus 3.